you look at this picture here, this is like one part of the bow tie. Do you guys agree? You can make that triangle. Again, this is lesson 2. You can make that triangle in all of the quadrants. Okay, there's another one. So you have this radial arm that goes from the center, the origin, out to the edge of this circle, and you get a right-angled triangle occurring in all quadrants, and you can see the bow tie there. And we're going to make sure that we always draw our reference angles with the x-axis so that this occurs. And what's going to happen is the x is always your left and your right parameter, and y is always your up and down parameter, and they always will go with a corresponding ratio. So if you take a look at this triangle here, using theta, y is the opposite. Do you guys agree? And if we want to relate that to r, you can see here that the y will always go with the sine, and then the x, if you're using theta, x on the bottom, if you go with r, is going to be the cos. Okay, so you'll need to learn that. Y always goes with sine, and cos always goes with x, if it's drawn like this. Okay, so just put a little notes for that. Before we get into all that business, we'll start with the Pythagorean theorem. And we talked a little bit about this yesterday in the notes as well. Okay, so let's take a look at this line by line. Here's the traditional formula that you're used to. But instead of using a and b and c, we're going to use x and y and r. So x and y are going to be similar to, yeah, that's good, McKenna. X and y are going to go with a and b. And then the r will be analogous to the c. Okay? Now it's going to tell you that some point, x comma y, lies on the terminal arm of angle theta. So here is your point. Put a big dot on that. Call it x comma y. This is your point P. Okay? Point P is x over and y up. Up or down. Left and right, up and down. So that's your point xy. Now the distance from the origin is going to be the length of this hypotenuse r. Okay? And you get this formula right here. And if you'd like to solve for r, of course you square root the other side. And we just did a whole unit on radicals. So the expectation is that you're going to be reducing your radicals like last unit. And that's why we do that in that order. And that's why this book is in this order. So stuff that you've done in the previous unit is going to build into the next unit. Let's take a look at this first example. Sketch the rotation angle in standard position and calculate the exact distance from the origin to the given point. Where appropriate, write the answer in the simplest radical form. So that's basically what I just said. Okay, so let's give yourself a crosshair. You know, I got rulers up here if you want to be neat. I noticed Manira, her line's kind of like crazy. So if you want to grab a ruler, that's cool. You know, ID cards work just as well, right? So get in your axis. I think it's better if it's organized. Just when you look at nice, neat notes, it's easier on the mind than if you look at sloppy notes, I think. Yes, just sloppy notes are stressful, I think. Okay, so let's take a look at this point. It's left 5 and up 12. Okay, so it doesn't have to be perfect. So what I like to do is go 1, 2, 3, 4, 5. You know, somewhat decently spaced out, the same. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So somewhere up there. And then I'll draw my radial arm to that point. And then I will draw in my two components that get me there. And remember that this is a graph. The graph has two dimensions. It has an x dimension and it has a y dimension. Okay, and you can see that clearly in the diagram. So we know that this distance is 12 and this distance is 5. And the negative, of course, just indicates the direction. The length of that triangle's x component is 5. The negative tells you it goes left. The length of that arm's y component is 12, and the positive means it goes up. So again, positive and negative just gives you direction, and the number tells you the length. They want us to probably solve for the length, right? Exact distance. Again, what does this exact mean in math? I'm going to ask one person in particular. You know who you are. Exact. What does it mean? No decimals, right? Right. No decimals, okay? So let's find this value r. R is equal to x squared plus y squared square rooted. Do you guys agree? What happens when you square a negative value? Positive, right? So that'll become 25. And this becomes 144. This is actually a perfect one. I remember this one. So 25 and 144 make 169, and that has a square root of 13. I know that one. So there's your value for r. Okay, let's do this one more time. This time a different point. So for point Q, both of the components, x and y, are negative, so we live in quadrant 3. Good. And up here we are in quadrant 2. So we go how much to the left and how much down? So there we are. And we draw in our radius. And the radius will have two components, an x and a y. The x is 2 to the left and 6 down for the y. When you go to solve for r, negative 2 square plus negative 6 square, and the result will all be square rooted. So we have 4 plus 36. This one is root 40, which is basically 4 times 10, right? The 4 will come out as a 2, and you're left with 2 root 10. So there's your value for r. So we're going to use our radical skills. And the nice thing about when we're in this trig, like the radical skills involved will usually be pretty simple. It won't be, you won't have some of those intense questions that you had on the written response. Any questions so far about calculating the r value? Will the r value ever be negative? So you can put a note there. R is always positive. Okay, now we can do the ratios like I introduced with how to start the lesson. So back in grade 10, or whenever you learned trig for the first time, for me it was grade 9. For you guys it's probably grade 10. If you came from a different country, who knows. But it's pretty standard that the opposite divided by the hypotenuse is the sine ratio. So if you want to talk about the sine of an angle, it's going to be equivalent to a ratio of the sides. The opposite divided by the hypotenuse. The companion to sine, that's why they call it cosine, is the adjacent divided by the hypotenuse. So sine and cosine, they're brother and sister, and they both use the hypotenuse. One's the op, one's the adj. And then the tangent is like the ugly cousin off on his own who does not use the hypotenuse, and it's just going to be the opposite divided by the adjacent. And this is what they've decided to call sine, cosine, and tangent. Okay? And they have wonderful results because all these triangles, no matter their sizes, if they have a similar ratio, you're going to have this like equivalent results just because ratios are equivalent as well. And everyone memorizes this as SOHCAHTOA. Now when you get into higher levels of math, they try to standardize it even further. Rather than using op and hype, even though it is the same and is true, they're going to put it on the coordinate plane, the two space, the graph basically, and they're going to use x, y, and r. X for your left, right, y for your up, down, and r for the radius. And they use r for radius because, and you don't have to draw this, but just watch, that r value, if you just rotated it around, you would get, this has to be in the middle, you would get a circle, right? That radius would spin all the way around, and you'd have a circle. Go away. Okay. Okay, so the sine of this reference angle, you can put that little note there. It's always going to be the reference angle, always. The sine of theta will be the opposite, which is y, divided by the radius, which is, or the hypotenuse, which is r. And cos will be the adjacent, which is x, divided by the hypotenuse, which is r. And tangent will be y over x. Question? And physics students, remember when I gave you those formulas for like r cos theta and r sine theta equaling y and x? Again, that's only going to work if the triangles are in this like bow tie fashion. Okay? For the physics students. Yeah. That's what we're about to get into. That's a good question. We're about to see that. I think on the next page. Yeah, determining the sine. Yeah, in a couple pages we'll get there. So good question. Yeah, I'm mentioning this thing about memorizing. What I always memorize is sine goes with y, cos goes with x. And we all know sine and cos goes with hype, so that's the r. Okay, so that's what I always memorize. Okay, this point is 15,8, so it's 15 over and 8 up. Calculate the value of r. So that's typically always done first. Em, you with us? Okay? Okay, we go 15 square plus a 8 square. So help me out, 225 and 64, I think. And help me out, 289, is that 17? Okay. So here we have r being 17. Now we can go ahead and find all these ratios, okay? So sine theta will be the y over the r. So it's going to be 8 over 17. Cos theta is going to be the x over the r, which in this case is 15 over 17. And then tangent, the crazy brother or the crazy uncle off on a tangent, is your y over x, your 8 over 15. Okay, so what you can do right now, just to see if this is all going to mesh, do the second function of sine for this ratio. Do the second function of cos for this ratio. And do the second function of tan for this ratio. And see if you get the same angle. And you should. Okay, so like usual, I tend to ignore these investigations and just get into it. So determining the sine of a trig ratio. So let's start in quadrant 1. This is the quadrant that we're the most familiar with, where everything's positive. So in quadrant 1, do you guys agree that x and y are positive? Yeah, that's the convention that we've made. We think that right should mean positive. Like, I don't know why. But right is positive, and so is up. So right and up, the x and the y are both positive. So then what we want to do is draw a conclusion about the sine, cos, and tangent ratios. So if sine is equivalent to y divided by r, and we know that y and r are both positive, then we know that this sine theta is going to also be positive. Does that make sense? And cos theta for quadrant 1 is also going to have a positive over a positive, which is positive. So you're thinking about yourself, the multiplication rules, like a positive times a negative. It's the same for ratios. And tangent is y over x, which is a positive, divided by a positive, which is also positive. So all the ratios are positive in quadrant 1. And you can put a big fat A right there, which stands for all. So every day you wake up, the sun rises in the and sets in the, so let's go over to the west quadrant. Quadrant 2. Now the sun is setting. You can see this is the sun up here. This is the sun right here. It is now on its descent. You can see over in quadrant 1 the sun is like rising this way and then it's coming over here. So let's take a look at this coordinate, x comma y. So for this quadrant 2 side, let's get these formulas in. Let's just get the formulas quick, and then we'll talk about them. Thank you, dear. You just saved me. Okay, so for these formulas, we know that in quadrant 2, is quadrant 2 on the left or the right? And we know that the left is negative, and it's up, so positive. So the x is negative, and the y is positive. Why don't we put those little notes there to help us? So y over r is going to be a positive divided by a positive, because r is always positive. And the x over r is going to be a negative divided by a positive, which we know to be negative. So there's your first negative ratio. If you're in the quadrant 2, the cosine of your reference angle will be negative. And tangent is going to be a y over x, so a positive divided by a negative, and it's also negative. So which is the only ratio there that's positive? Sine. So put a big fat S right there. And this is what we have so far. We have quadrant 1, we have all ratios positive. Quadrant 2, we have just the sine ratio positive. Now we're going to pop down into quad 3. Again, just getting these formulas down. And if you write down these formulas enough, they'll probably get committed to memory. So in quad 3, both the x and the y are negative. So when you go to do sine and cos, you'll have a negative divided by a positive for both of them. So both sine and cos are going to be negative in quadrant 3. But what happens when you get to the tan? Negative divided by a negative is a positive. So the only ratio that's positive in quadrant 3 is tan. So put a big fat T. And then lastly, we have quadrant 4. Again, just jotting down these formulas. And for the sine, or let's just get x is, for quad 4, you're on the right, but you're also down. So x is positive, and y is negative. Very nice. So for sine, it's a positive divided by a positive. No, my bad. Negative divided by a positive, so sine is negative. And cosine is positive divided by a positive, so you get positive. And tangent is y over x, a negative divided by a positive, which is negative. So the only one there that's positive is the cos. And we've got this ASTC acronym that I'm going to ask you to memorize. Question? Cats? If you did the bow tie? Kind of like this. Cats? I like that. That's pretty cool. The one that I memorize is as it follows the path of the sun. You know how it rises in the east and sets in the west? So you go this direction, which I also like because it goes, 1, 2, 3, 4 in that order, is add sugar to coffee. Okay? So that's a good way to remember it. Add sugar to coffee. And it's in the book. That's what follows. Add sugar to coffee. And what they call this in the book is also, and what most people in the world that do this stuff, they call it the Cass rule. Okay? And you can see here, add sugar to coffee. But I like that Cass. That's good. So this page is wrapped up. So part C. Okay, before we get to part C, let's just look at this. So let's first talk about the sine. Let's look at the sine in terms of the sine ratio, highlighted in blue. So in the top, sine is positive because sine goes with the y's, right? And you'll notice that in the bottom, sines are negative. Now let's take a look at the cos. If we look at the cos, since it has to do with the x, if you look on the right side, notice that the cosine is positive. And on the left, you'll notice that the cosine is negative. And then the tangent, the weird one, because tangent is a ratio of y and x, whenever they're the same, it'll be positive. So if they're both negative or both positive, the tangent will be positive. So that's quadrant 1 and 3. And when the signs are different, like in quadrants 2 and 4, signs are different, you get this negative business. Okay? So usually students remember that sine up here, upstairs, for positive, downstairs for negative, and then for cos, because it's the x, over to the right, positive, and to the left, is negative. So you could fill out this chart if you'd like. Sine ratios are positive in the top. What is that? 1 and 2. And they're negative in the bottom. So 3 and 4. And then cosine ratios are positive on the right. So what's that? 1 and 4. And cosine's negative on the left. So that's 2 and 3. And then tangent ratios are positive when they're the same. So 1 and 3. And negative when the signs are different. So 2 and 4. And the reason we need to know the CAS rule is for trig equations. You have to use the CAS rule for trig equations. Okay, class example 4, determine without technology, so without your calculator, whether the ratios are positive or negative. So 340, where's that? Quad what? Well, why'd I do that? Is 4 like that? So sine 340 is negative, less than 0. And if your calculator is in degree mode, hit sine 340. See what happens. Comes out negative? Yeah. Tan 227. So where's 227? That's quad 3. In quad 3, the x's and the y's are the same. So tangent will be positive. 88, that's quad 1. And that's up above, upstairs. So sine 88 is positive. 235 is in quad 3, so cos 235. If you're in quad 3, you're on the left, so cos is negative. 308 is in quad 4, so that's on the right, so cos of 308 is positive. That's a terrible sign. And 123 is quadrant 2, where the signs are different. So 123 tangent would be negative. I don't really use this. You can use it if you like. It's just going to be comparing it to the reference angle. So if you're the type of person that doesn't like too much in their life, like, you can skip this question. Less than 0 means negative. Greater than 0 means positive. Does that make sense? Okay. Okay, class example 5. We will class example 5 is using this, so I guess we don't cross it out. I don't know. I think it's just, let's just do it, and then you can go look back at that and see if it's worth reading. Okay, so let's draw in a grid. And let's do 140. Where's 140 going to live? Second quad. It'll be what, like 40? What's the reference angle for that one? 40. So there's 40, and here is 140. So sine 140 would be the same as sine 40. Does anybody want to hazard a guess why? Very nice. Okay, so sine 40, that would be if the reference angle was here in quad 1 with 40. And if you notice, they would have the same height. So the sine of 140 and the sine of 40, it's the exact same y value. Do you agree? And the radius is the same. It's the same radius. So that means these two things have to be the same. Let's try another one. Tan of 323. Where's 323? Quad 4. So, and again, the bow tie is here to help you if you forget. Reference, 180 minus reference, 180 plus reference, and 360 minus reference. And it's the same for the rotation. So just go 360 minus 323, and you get 37. So 37. Okay, so if we wanted to use the 37 up here, because that's what they want us to do. They want us to use the acute angle, which is the quadrant 1 angle. What's the relationship between this and this? Yep. Okay, so this position is x comma y. This position is x comma negative y. Do you agree? So how will the tangent ratio for 323 compare to tangent of 37? Very nice. Oh gosh. Let me just rewrite this so it's neater. So tangent of 323 is equal to the negative of tangent 37. Because it's like the y over the x. In this case, the y over x is positive, this one's negative, so they're equivalent just up to a sign. So go ahead in your calculator, type, please, in degree mode, make sure degree mode, hit tan 37. And then hit tan 323. And they should be the exact same ratio, but one's positive and the other is negative. Okay? So, boom. Let's just do maybe one more. Let's do cosine of 165. Reference angle for 165 would be quadrant 2. The reference angle is 15. So it'd be 15 over here. For cosine, we look at the x, right? And we don't, for cosine, we don't care about the y. So how do these two relate to each other? So to think about these ones, you have to think about x distance. So for cosine of 165, which is over here, and cosine 15, which is right here, the distance is the same across, but they just go in the opposite direction. So for cosine of 165, way over on the left, and the cosine of 15 over on the right, they have the same x position, it's just different sign. So the distance is the same, but different sign. So how do they relate to each other? Well, cosine of 165 would equal the negative of cosine 15. Okay, so I think we'll stop. We don't need to do 3 more of those. They're all very similar. Yeah. Okay, so, and then these ones, I don't really like these because it would be better if we had the graphs. So if you're like an AP student, I would get to know this, but you know, I wouldn't worry too much about it. So assignments, I've seen that the teachers want us to do 1 to 11. So it's only a couple pages. So your math homework's not too intense today. So big ideas today would be the cast rule and the finding the R. This will be on your quiz for sure. This will be on the test for sure, finding the R, and then the corresponding trig ratios that go with it. So this here, like this example here, for sure on your test. Absolutely. Okay, so you're going to be given a point, you find the hypotenuse, you write down the 3 ratios. That is a guarantee. Every year it's on that test. Okay? And then the cast rule, it's going to be built. We're going to build on this for when we get to trig equations. So you need to be aware of the cast rule and some of the relationships with position. Usually it's just amounts to the same position but on the opposite side. So for the y's, for sine, it's up and down. And for x, you know, left and right. Okay? For cos. And don't worry too much about this. I would not like memorize or that or anything like this. Okay? So that's it for me. You have about 20 minutes to work. Remember, no East today. And if you want to see your written response on your exam, tomorrow during the East block when E and N is going, you know, you can peruse your exam.